Okay, let's look at the last topic. Actually, two topics, actually. In connection with 2 times 2 matrix. Okay, we want to solve for K1 and K2 from this column factor in the following equation. So in other words, it actually means AK1 plus BK2 equals E11, and then CK1 plus DK2 equals E21. It means two equations. But instead of using simultaneous equation method, you rather are forced to use the matrix method to solve for the two unknowns K1 and K2. Okay? So for the matrix A, 2 times 2 matrix A, this time I rather use A, B, C, and D to represent the four entries instead of A11, A12, and so forth. So A, B, C, and D, the two unknowns, K1 and K2, then E11 and E21, they are given to you. So the elements in A and E are given, but K1 and K2 are not given. You have to solve for K1 and K2. Okay, we start off with the first method, the determinants and the inverse method. So after deriving this system of linear equations, okay, we must first derive the determinant of matrix A. So determinant of matrix A is derived as AD minus BC. Okay, so keep this equation in mind. Okay, it's not going to be given in the formula sheet, so you must remember that. Then we move on to derive the inverse matrix of A. It is A then to the power of minus 1. It is derived as 1 over the determinant of A. Remember, this is the determinant times the matrix A, but you swap some of the elements around. A and D, they have their location swap. Do you notice that? B and C stays, but you have to add the negative sign. Okay. And you have to notice that 1 over the determinant. So the determinant cannot be 0, because if 1 over a denominator which is 0, then this whole thing would be undefined, and it actually means inverse would not exist. Okay, and the reason why we need to have a specified inverse of matrix A is because this is how we solve for the unknowns. The unknowns are solved as the inverse of matrix A times the element in matrix E. So this is how we solve for K1 and K2. Okay. In order to fully understand the method, let's do a question actually. Chapter 6, question 5. Okay, we have got two equations, supply and demand. So let's first sort out the two equations as follows. So actually, you just have to rearrange the terms. It actually means 5p minus q gives you 30. Okay, look at that. 5p minus 1q gives you 30. And then the other one, you actually have to move the 17p to the left-hand side, and actually 17p plus 1q gives you 124. Look at this, 17p plus 1q gives you 124. Okay, happy with that? So this is your matrix A. That's actually K1. K1 is now P. K2 is your Q. Then E, you are given the information. Determinant of A is AD, which means 5 times 1 minus BC. B is minus 1, C is 17. So the determinant is 22. Good news, it is not equal to 0. Then we move on to derive the inverse of matrix A, which is 1 over determinant. You can, okay, it actually means 1 over 22 times the so-called new matrix of A, because you have to change some of the elements. Remember, A and D have their position swap. Do you see 1 and 5? And the other two terms, B and C, stays but multiplied by minus 1. This is why now this term becomes minus 1 times minus 1, that gives you 1. And then this term 17, you multiply by minus 1, then it gives you minus 17. Okay, then we simplify it as follows. Okay. And then K, which includes P and Q, would be the inverse of A times the elements in the column factor E. Okay, I think we first sort out these calculations. It means 1 times 30 plus 1 times 124. This is why I have 154 here. And then the other one, minus 17 times 30 plus 5 times 124. That gives you 110. And then each element divided by 22, 7 and 5. It can actually mean scalar multiplication. It means each term is multiplied by 1 over 22. But now we know the answers. P is 7, Q is 5. Okay, and then now for the next one, question 6, we have two unknowns, P1 and P2. This time I don't want to say a word. I want to keep quiet. So I want you to see if you can understand the answers of 6.1. So let me stop for 1 minute. Okay, then the last topic is we want to solve for the two unknowns, but this time we use the Cramer's rule. Okay. These are the procedures. First of all, we still have to derive the determinant of A. You already know the equation AD minus BC. And then next we derive a new matrix A1. You might ask, where does it come from? It actually means replacing the first column of A, which means this column AC, with the values in the factor E. So do you see the replacement here? A and C, the first column, is replaced by E11 and E21. So this is how we derive matrix A1. And then for this matrix A1, we derive the determinant. So it is E11 times D minus B times E21. And then finally, we solve for the first unknown K1 as follows. Determinant of A1 divided by determinant of A. Okay. And then we derive the next matrix, matrix A2. This time we rather will replace the second column of matrix A, which means B and D, with the column E factor entries. So do you see the changes here in the second column? Sorry, this is A2 actually. Good for me to pick up the typo error. And then derive the determinant of A2, which is A times E21 minus E11 times C. And then you solve for K2 as determinant of A2 divided by determinant of A. Again, if you just look at the procedures, it might confuse you a little bit. So in order to fully understand it, let's do the questions. Okay. Question 6. Chapter 6, question 5. Remember, we already did 5.1 using the normal inverse matrix determinant method. Now we rather use the Cramer's rule. So this is my original matrix A. Determinant, still the same thing, 22. And A1, do you see I replaced the first column of matrix A with the E column factor data, 30 and 124. So this is my A1 matrix. And then I derive the determinant of A1, 30 times 1 minus 1 times 122. So you have 154. And now we can solve for the first unknown K1, which is P, which is equal to determinant of A1, 154, divided by determinant of A, which is 22. So you see we get the same answers again, 7 as in 5.1. Okay, and then the next new matrix A2, we replace the second column of matrix A with all the E column factor data. So you see the changes here, 30 and 122 in the second column. Then we derive the determinant of A2, 5 times 124 minus 30 times 17, 110. Then finally, your second unknown K2, which is your Q, is equal to the determinant of A2, 110, divided by the determinant of A, 22, then 5. Remember, we got the same answers previously. Okay. So now to do it one more time, Cramer's rule, I want to redo question 6, but this time with the Cramer's rule. So can I just keep quiet this time and see if you would understand the answers? So remember, this is my original matrix A. So let me stop for 1 minute. Okay, so that's it. Okay, the fourth math eco topic, matrix. Then we only have one last topic, which is the integral calculus. Okay, so see you then.